Hello everyone, this is a video demonstration of FIT5225 assignment 1. Let me share my screen. So this is the code of the web service that was created. So what it does is I've created a method called as main, and this maps to the root slash API slash object detection, which is the API endpoint, and this of the type post, so that we are able to send some request parameters into it. And then I'm just extracting the parameters from the request parameters using request.json, which will give me the JSON. And I'm converting that back into a dictionary using the JSON.loads. And after that, I've just retrieved the parameters such as the image and ID, which I'm sending from my client.py file. And this image is getting decoded back into its original format over here. And then the rest of it is as what was given as a part of our assignment. And then over here, I'm constructing the JSON response over here. So I have a for loop which goes through each of the detected items. And for each detected item, I'm just constructing a dictionary, and I'm appending that at the end of each iteration into a list called as objects. And then I'm setting that to the overall API response dictionary object, and I'm naming that key as objects. And then I'm just converting this dictionary back into the JSON format using this JSONify function or the API. And once we have that, now let's take a look at the Docker file. So if I open my Docker file, so the base image that I'm using is from Ubuntu. And then once the base image has been installed, then I'm installing a few necessary packages over here, which are required so that YOLO runs smoothly on them. And then I'm also installing Python 3 along with pip, and also a few other required libraries. And then I'm just copying the requirements.txt file into this local Docker image, which contains the list of all the necessary packages and libraries required to run YOLO. And then I'm setting my work directory to app, and then I'm just updating my pip3 before using pip3 installer to install all the required libraries in my requirements.txt file. Then what this line of code is doing is copying all the YOLO config files which I've uploaded into this instance using WinSCP to this Docker image, so that the code can run easily and it should be able to find where the config files are located. And then I'm setting the entry point and the command as Python 3 space app.py, so that this line or this command will bring up my Flash server and I can access all my API endpoints. So this is what the Docker file looks like. Now let's discuss a little about the Kubernetes cluster and the service. So for that, I've already set up my cluster and the service. All I have to do is just show you what are the pods that are running. So the pods, you can see I have 3 pods up and running over here already, and all of these 3 pods are running on this particular worker node. And my cluster consists of 1 master node and 1 worker node, which is what was specified in the assignment as well. And the service is acting as a load balancer, which was also a requirement that was specified in the assignment. Now let's take a look at the YAML files. So what I'm going to do is nano first the deployment YAML file. So the deployment YAML file is responsible to install each of these Kubernetes pods for us. So I set the number of replicas initially to 1, which is again a part of the requirements. And then this label is very important. I've set it to object detection, and I'll be discussing about this in a bit. And then I've set the image as this over here. So what I've done is I've pushed my Docker image, which I built locally, into Docker Hub, and I have created my own account. And from that, it's able to retrieve the image for us, which will be installed into the Kubernetes pod. And I'm exposing port number 5000 over here. And I'm also setting the CPU resource limit to 0.5, and also setting the request limit to 0.5, which was a part of the assignment requirement as well. Now let's take a quick look at the object detection service file. So over here, it's of the type service, and this type of the service is a load balancer, which was a requirement of the assignment. And then this selector, as I mentioned, is very important. It should match the same name as that what we have given in the deployment YAML file, so that the service is able to map to all these pods running on the nodes in the cluster. And I'm exposing port number 80 so that we can access it from outside. And I'm also setting the target port as 5000 so that the service can map these incoming requests coming from outside into the pods running inside the cluster. And node port is what is responsible to forward these outside incoming requests into the cluster, and I'm using the port number as 3275. And then now I'll just quickly go to my Nectar instance and show you my security rules. So I've exposed port number 5000 so that I can access all the pods running inside my cluster. And I've also exposed port number 80 so that I can make these API calls by using port number 80, which in turn will go into the service, and the service will do the internal mapping for us. And also the instance is up and running inside my personal project, and the IP address is what you can see over here. Now, as a quick demo, let me go to my Git bash, which I'm running locally on my system. And I'm just going to run this command, which is client.py, and I'm setting the number of threads as 6. And you should soon be able to see all the responses coming over here. And once we have the responses coming, I'm just going to use cube ctl logs and specify this pod, for example. So you can see that it was able to receive quite a few number of requests. And lastly, let's also look at one of the other pods. And all I'm going to do is cube ctl logs and do it again. And you can see that this pod also retrieved or received some of the incoming requests. And this was because the service was acting as a load balancer, and it was transferring all the requests on behalf of us. So that's it for this video presentation. Thank you so much.